Okay, hello, dear friends. Good morning. Such a beautiful, beautiful. I think this is a Saturday morning. Yes, a beautiful Saturday morning, and I went to Sausalito, a little bit north of San Francisco. Here is my outfit of the day. I want to walk around, and I wear these comfy shoes and these leggings. Mm-hmm. 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 Oui, c'est comme ça. And it's very easy to walk around with the legging. I can sit very comfortably. And I came to this place. It's called Bay Model. It's U.S. Army Corp Engineering Corp， 美国陆军工程兵团，美国陆军工程兵团。我一说工程兵团，你就可能想出来了。So this is a military model, and the story is very interesting. I came to Sausalito. My husband did sailing, and he told me there is a place you need to check out. It's called Bay Model, and it's about the water system in the Bay Area. So I searched online and found this is actually a very fascinating place. And outside is beautiful. The day before there was rain, and suddenly the sky opened up, and just such a blessed day. So here's the story. After World War II, America was very much developing, and there was a guy. His name is Jonh Reber, and he thought that San Francisco area need to have clean water and plain water, not salty water. You know, California is always short of water, and this idea has been long exist to search for water. The search for water, the pursuit for water, is an endless pursuit, endless search, endless struggle for California. And San Francisco with Golden Gate Bridge, and with Pacific, it's a very strategic, important point. And at that time, people's understanding or technology or science has not yet developed to have a whole understanding of our world, or how to preserve, to take care of the world. So Jonh Reber, this gentleman, he was from entertainment business, and theatrical producer, or make big productions, performance, entertainment productions. But he was very ambitious, and so he thought, maybe I can think about an idea. This idea was not very scientifically sound, but he really was very ambitious. So he thought to block the Golden Gate Bridge, this area, this San Francisco Bay Area. So block the water, and so the Sierra Mountains water come down. We'll have a drinkable plain water, clean or fresh water instead of seawater, and build a big dam. Oh, here, I need to show you this. This is the white are the snows. Oh, you can go up to see the white points are the snows, the snowfalls from the Sierra Nevada mountain area. And in summer, it starts to melt and make this make fresh water, and then the river water goes to the sea. And that little bay area is San Francisco area. And at that time, we or people had not yet understood very well about this estuary and estuary ecosystem. Actually, this melange, the mixture of salt water and sea ocean tide, ocean stream, and river water, actually produce a very unique ecosystem. At that time, people has not yet understood that. So he wanted to build a dam, and a huge dam, to stop ocean water entering into the San Francisco Bay Area. And this way we can have fresh water, and build a big dam, and on top of the dam to build factories, build ship, build building, build factory, transportation, and everything. And he was very ambitious, and his idea was actually got a lot of critics, and got some people enthusiastic about. And his idea got into the discussion, and the U.S. Army Engineering Corp decided to make a study. They made a study, and they started to make a model. And this is the model. What we are seeing is the model. This model shows how to build this dam, and if the dam was built, how the water flow will change, and how it will influence the eco-biological and ecosystem of the Bay Area. And this model was built on huge concrete and many blocks of concrete together, and with some copper sensors. Later on, you will see the points of copper sensors to see the water flow, and all these technical things. So in longitude, in the length, it's 1 to 1,000 proportion, and 1 to 1,000 ratio. Let's say if here on this model is 1 meter, then on real life will be 1,000 meter, that kind of longitude. And in altitude, it's actually 1 to 100, because if you make 1 to 1,000 the same portion, same ratio, you cannot measure the water change. And so they make some coefficient, and it's actually quite complicated. And my husband said, you have to ask. One is 1 to 1,000, and the altitude is 1 to 100. It does not make sense, and there will be some distortion. And actually, the engineers thought about this distortion and have some coefficient to calculate and make it as accurate as possible. So this is a model to see how to build this dam, how it will influence the local environment. And the end result is that it proves that this project, this Mr. Jonh Reber's Reber Plan, is totally Reber. I think Jonh Reber Plan is a total disaster. It does not work. And this is one of the things that is really interesting. about when there is an idea, people bring it up, and it's a purely scientific proving system, and I'm fascinated by it. So this guy, this very ambitious gentleman, he had a hypothesis, and then people get into an action mood to really prove it. And the result is that it proved that it's wrong, and everybody accept. And then this project didn't get into action. Actually, this Jonh Reber, this gentleman, provided $2.5 million for this project. If you think about the inflation rate, there will be 2.5, $20 million, $30 million for this Bay model project. Anyway, so that was before the computer simulation existed. Starting from 2000, you see here, you can see. And so longitude and altitude is 1 to 1000, 1 to 100, and the time is actually 1 to 100. So every 4 minutes there will be water coming up, coming down, a tidal, a one tidal circle. So it's very, very interesting. And if you come here, especially if you are local here, you come here as if you are seeing your land. As I was walking at Palo Alto, and I feel I was just stepping on that land yesterday, and then move on to Mountain View, Shoreline Park, and Alviso, all so familiar. And there is a feeling of going back home and just seeing what is happening in front of my eyes. And this model provided a scientific and visual representation of what human action will influence our living environment. And when the city administration, the government administration, the state administration decide some development project, when they decide to build something, to make an artificial island or some living quarter, they come here to see what is the influence that it impacts the environment, especially the hydrodynamic impact. For example, if the water level raise, what will happen to the surrounding area? And everything is up to proportion. And they measured the length of the depth of the water by radar sensors. And here is a pump, and this place is very, 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 very noisy. And to produce water and accurately up and down every 4 minutes, it really needs a lot of water power, hydraulic power for this. And so the landscape is very much accurate. But this is not Disneyland, this is not Legoland. And the Golden Gate Bridge was not pretty, Bay Bridge was not pretty. All those decorative things or or non-functional in this hydraulic representation. If it does not help in this hydraulic or hydrodynamic representation, it was not emphasized. They emphasize on the accuracy of the land shape, water, the river length, the river depths, the delta shape, and surrounding airport, things like that. So if you come here to see the Bay model, the Bay Bridge model or Golden Gate Bridge model, you might be disappointed. So this is Bay Bridge, what we are seeing right here. So it's not so glamorous. And you will see there are these copper dots. They are the sensors. They sensor the water change and water pressure change, and all these things. Very, very interesting. And so this place was used from 1957, I think, around that time. After World War II, 1957 started to put in action, especially for the Jonh Reber, the Reber project, Reber Plan. And it has been used very, very effectively at Golden Gate Bridge, effectively and efficiently until 2000. And after 2000, there are computer digital simulation which can do more detailed and more accurate simulation. If water comes, or if land raises or land goes down, what will happen? Computer can do better job to do more accurate job. So this place from a functional military or administrative a function tool or a function resource becomes into an educational venue. I saw some kids came here, and myself, I enjoy very much coming here. And there must be quite some school trips coming here, and know my land, know the land where you step on is very interesting and very educational. And I thoroughly enjoyed this experience. And it's about two football field. I have no sense of football field. Anyway, I have spent around 1 hour or 1 hour and a half around that time, and there are a lot of readings there. And because I live there and I have been to all these places, so I try to figure out, oh, this is where and where, this is where and where, which direct point I'm standing on. I try to figure out it because it's very interesting. It's so close. It's touch base and touch home. And it is a very, very interesting and fun educational venue, especially for people who is interested in hydrodynamic, interested in science, interested in modeling in this Bay model site. So yeah, this is the site where we are, and interested in this diorama. It is just perfect. the condition is it looks very very basic, and make it more authentic, more original, and more real. And they are expanding some Sacramento Delta in another corner, and yeah, that's about it. If you pass by San Francisco, and this is one of the truly amazing place. It's I feel it's beyond tourist. It's not just take a picture and see the place. This is just touch my home, and very, very good. And this is Petaluma. Yes, Petaluma River. So we can understand, because of the river, the civilization always come near river, right? Because of the transportation. Before road transportation, before train, before car, and river transportation was vital for transportation, communication, and economic development. That totally makes sense. That why Petaluma was such an important place. And I will do another video about my trip to Petaluma, and it's a very, very, very interesting trip also. So that's about it. If you come here, go to see this, because and another thing is free, and you can give donation to contribute for this good work, but otherwise it's free. And I really appreciate how much I'm changing seat, how much they have put into it. So that's the end of this beautiful, wonderful trip. And I came out, sunshine receiving me, and river hayaki. Or I thought about this reminds me of my hayaki in Vancouver, Canada, yeah, with my husband for many years ago. So enjoy sunshine, enjoy science, enjoy everything. Oh. You have a beautiful, beautiful, beautiful day. I love you. I really do. Do. Bye bye, friends. Goo bye bye. Oh, so good. Sunshine on my shoulder makes me happy. Goo bye bye.